For the hockey puck, we have initial speed of 12 meters per second, but it's slowing down, it's eventually going to stop. So, the final velocity is 0. The beginning velocity is actually 12 meters per second. We want to find the acceleration if it slides 60 meters before stopping. Anybody find the acceleration yet? Yeah, negative 1.2. Negative because it's slowing down or stopping. So then we can use F equals ma. The problem is, we don't know the mass, but the reason this one is different is why does the puck stop? What force is causing it to stop? Friction. Friction is our net force. So if our net force is mass times acceleration, and our net force is equal to friction, what can we do with these two equations? Man, there it is. So now we've got mass times acceleration is our net force, which equals the coefficient times the normal force. And if you're looking at this puck, how do we find the normal force? Normal force is equal to what? Yeah, same thing as the weight. What do we have on both sides that could cancel out? Yeah, we don't even need to know the mass. If you're not given the mass, it might be because you don't need it. So now if we want to find this coefficient, I'm going to have the acceleration divided by gravity. To get the coefficient. So let me just kind of explain again the steps, like what happened there. First of all, we had to find the acceleration. If you don't know the acceleration and you're trying to do F equals ma, find the acceleration first. Then, the force of friction is the net force. It's slowing down or stopping, kind of like the car that had the brakes. We set the force of friction equal to the net force. Same thing. We were able to cancel out the mass because it's on both sides. Solve for the coefficient, got 0.12. These are examples very similar to some of the multiple choice. Other multiple choice will ask you about like Newton's laws. Like for instance, you remember what Newton's first law is? Law of inertia. An object in motion tends to do what? Stay in motion. If it's at rest, it tends to stay at rest. It's kind of like in the worksheet examples you have. There's a girl sitting in a wagon or a boy sitting in a wagon. I don't know, somebody sitting in a wagon. You yank the wagon, they seem to fall back. It's really messed up. Don't do it. But that's Newton's first law. The kids has a natural tendency to stay at rest, but you pull the wagon, they fall back. Or when you're on the skateboard, you're going at a constant speed. If the skateboard suddenly stops, you feel like you fall forward. That's Newton's first law. Newton's second law is just F equals ma. It's that relationship between the net force and acceleration of an object. Newton's third law, for every force you have a what? Equal and opposite force. If you kick a soccer ball with 30 newtons of force, the soccer ball applies the same 30 newtons back on your foot. After the 10 multiple choice, you have 3 free response. First free response is a vertical pulley example. So what I would like you all to try to do is to try this example first, and then we're going to answer it together. Because if you just watch me do it, it might seem easier than it really is. So take about 5 minutes, answer this one. I'll draw the picture on the board, but basically we're going to have a mass of 2.85 and 3.25, both hanging down vertically.